I apologize for the delay. I tried to do this earlier and it didn't happen because my children demanded my attention. So, at any rate, we're going to do a complex shape here, which is number 3 on your 211 Centroids activity. The 3 shapes that we're going to do, we're going to break this into a 1, the giant square that's 2 by 2. We are going to, there we go, 2 inches wide by 2 inches tall. We're also going to look at this rectangle right here, which will be shape 3, and this semicircle right here, which will be shape 2. So, starting with shape 1, which is the easiest of the two. To find your y centroid location, our total y is 2 inches. To find the y centroid, remember we take our total y and divide it in half. So half of 2 is 1 inch. So our y centroid location for shape 1, which is the box, assuming shapes 2 and 3 are not cut out, just the box all by itself. And the area of that box of shape 1 is 2 inches by 2 inches, which gives us a total of 4 square inches. When we multiply those two together, 4 square inches times 1 inch, we end up with 4 cubic inches. So I'm just going to copy and paste this and change this to a 3. So 1 times 4 is 4. We've done our y centroids for this shape 1, which is the giant square. Now let's do the x's. So when you're doing x centroid, again, same thing. You take the whole x and divide it in half. The whole x is 2, as you see down here, so we're going to divide that in half. 2 divided by 2 is 1 inch. And the area we've already established is 4 square inches. And when we multiply 1 inch times 4 square inches, we end up with 4 cubic inches. So, that addresses this first box, which is the easiest of the 3, I would assume. So, now we move on to shape 2. Shape 2 is the semicircle. Okay? As you can see, this semicircle is flipped upside down and at the top of the image. So, we're going to find our x and y centroids, and then we're going to have to see if we need to address them a little bit. So, let's start with the x, because the x is a little bit easier here. The x centroid for a circle is the radius, which in this case is 0.625 inches from here to here. So our x centroid, though, needs to be measured from this y-axis, because we need to know from this origin, how far over do we have to go and how far up do we have to go. So as you can see, the centroid of this semicircle is going to land on this line. Well, this line is actually a line of symmetry, which goes right down the center of this whole object, which is at the 1 inch mark. So the x centroid location is 1 inch. I could find that by doing 0.625 and then trying to figure out how much space this is right here. Or I can look right here and it's measured out for me, 1 inch from here to here. So at any rate, the x centroid is at 1 inch. The area of that circle, or semicircle I should say, is pi r squared divided by 2. We have to divide it by 2 because it's only half of the circle. So when I pull up my calculator here, I'm going to do pi times my radius. My radius is 0.625 pi r squared, so I'm going to multiply it by 0.625 again, pi r squared. But that's the area of the entire circle. We're only talking about half of the circle, so I'm going to divide that by 2. And when I do, I get 0.614. So I'm going to put 0.614 inches squared. Now, one thing that I have to point out here is this semicircle is a void. It's negative space. It's been cut out. Our shape is the blue part. So this is not there. So our area has to be negative here, and that negative just tells us that it's negative space. There's nothing there. So when we multiply those two together, our x times our area is going to still be negative 0.614 inches cubed. Now we can come up here, and I know already that my area, since shape 2 is still that semicircle, the area is going to be the same, 0.614 square inches. But now I have to figure out what is my y centroid location. So if you remember, the equation for the y centroid is a little bit trickier. It is 4 times r divided by 3 pi. So I'm going to have to get my calculator back out and do a little calculation here. And I'm going to clear this out. 4 pi, pi times 4 equals, and then I'm going to divide that by 3. Sorry, I did that wrong. Apologize. 4 times the radius, which is 4 times 0.625, which is 2.5, divided by 3 times pi. So now I have to do divided by 3, and notice I went and did my parentheses, 3 pi times 3, and I'll close my parentheses there. And I come up with 0.265. So I'm going to put that in here, 0.265. However, that is how far I need to come from the base of this semicircle. So I need to come down 0.265 inches. This is where you have to remember that everything we measure has to come from the origin. So to get to this spot up here where my mouse is, I've got to go all the way up 2 inches and then back down this much. So really, to get my y centroid location, I have to do 2 minus that number, which is going to give me 1 point. Let's pull out our calculator here so we don't make a silly mistake. 2 minus 0.265, 1.735 inches. So that's how far up we're going to have to go to get to this spot right here, which makes sense. It's almost to 2 inches. I'm going to leave this in here, but I'm going to make it a little bit smaller so that the 1.75 is what's important. And then we're going to take that 1.75 and we're going to multiply it by the area. So I'm going to do times 0.614, which leaves me with 1.065 inches cubed. Now, my last shape is this little rectangle right here. And I've got, oops, sorry, that's a negative 1.605 because that is negative area because this part is cut out. Okay, so now the third shape is this one right here, this little rectangle down at the bottom. To find our y centroid location, it is 0.5 inches tall, so we take half of the y, which gives us 0.25 inches as our y centroid for this. And since it is sitting on the x-axis, or the y equals 0 axis, we only have to come up ½ an inch to get to the centroid. We don't have to add anything to the y. The area of this, we have to multiply our length times our width. So we need to figure out exactly what our width is. If you notice, from x equals 0 to this side is 1.375, and from x equals 0 to the left side is 0.625. So the difference in those two will give us the width of that box. So we have 1.375 minus 0.625. And so 3/4 of an inch is the width across there. So our width here is 3/4 of an inch. And so if we want to find the the area, we're going to do 3/4 of an inch times 1/2 an inch, which is width times height, which gives us an area of 0.375 inches. 0.375 inches. And I know what you're thinking, but Mr. Goodwin, that is negative space. It's not really there. We need a negative sign. And you are so correct. So now, last thing we have to do in this chart, this row right up here for our y's, is multiply our y centroid plus our area. And when we do that, times 0.25, which gives us 0.094, negative 0.094 inches cubed. We can come down here now and address the x-axis. The area is going to be the same, so I'm going to fill that in first. 0.375 is our area. And now our x-centroid location. So we need to know what our x-centroid. Let's address it for just the box first. So if the box is 0.75 inches across, we have to divide that in half to get our x-centroid location. And we get 0.375. 0.375. However, that's not how, that's from here to halfway across the box. We still have to get this 0.625 and then go 0.375. So what we have to do is we have to take that 0.375 and add our 0.625, and we find out that we need to come over 1 inch to get to the midpoint in the x direction across this rectangle here. So this is actually going to be 1 inch. And I'm going to make this a little bit smaller so that it de-emphasizes it. But the most important thing is the 1 inch, which you notice is the same for the large square and the semicircle. We have a line of symmetry here at the 1 inch mark on the x dimension. That's what I'm saying. If you saw that, you're going to realize that when we do all these calculations, we're going to end up that our x-centroid is on the 1 inch. If you can recognize that from the beginning, that this has a line of symmetry right here, you can skip this whole box. But we're going to work through it because we want to learn, by golly. And so now we're going to multiply those two together, and we're going to end up with negative 0.375 inches cubed. And now we're going to solve for our totals. So we'll start in the x dimension. I'm going to bring my calculator up right over here. And so the sum of the areas. So I'm going to add these numbers, and notice some of them are negative. So I'm going to do 4 minus 0.614 minus 0.375, which gives me a 3.011 as my sum of the areas. And then over here I'm going to do, again, 4, come back to my calculator, 4 minus 1.065 minus 0.094, excuse me, which gives me 2.841. these are my totals. So I'm going to make them bold. And then I'm going to come down here and I'm going to do my same totals for my x dimension. So I'm going to start here with 4 minus 0.614 minus 0.375 equals 3.011, which I did up above, and I just had to redo it for no reason. And then I'm going to do the same thing here, and I'm noticing these numbers are exactly the same, so it's going to be 3.011. I'll bold these in so that we see our totals. So now I have my totals, and I can go down to the equations that were given to us. Oh, goodness. On the equation sheet. So for my y centroids, I'm going to do it is sum of y times a, which is 2.841, divided by the sum of the areas, which is 3.011. And when I do that, I get 2.841 divided by 3.011, 0.94, 0.94 inches. And then I can come down here and I'm going to do 3.011 divided by 3.011 because I'm doing my XA divided by my sum of my A. And when I do that, obviously, I get 1 inch. And so I have my XY pair of 1, 0.94. Bada bing. Oops. Right there. Hopefully this helps. If not, come see me after school. Training advisor.